All right, everyone, thanks so much for joining us for Weather Where You Are. Today we are talking all about the Northern Lights, also known as the Aurora Borealis. Some of you, if you were lucky enough, may have seen it yesterday, last night. A lot of people were able to see the beautiful pinks and greens in the sky. And some people could see it again tonight, but unfortunately, it doesn't seem like that's going to be in our cards. But we're going to talk about what causes them and again who could see them tonight, because there is another what we call geomagnetic storm on the way tonight, but it's not going to be quite as strong as the one last night. And then if you can remember all the way back to, like, it was, I think, July, we had a really strong one as well that gave a lot of us a beautiful view in the sky. Something that's on a lot of people's bucket list to see the Northern Lights, right? And normally you do have to travel very far north to the poles, and we'll explain why, up towards like Canada and Alaska. That's where you really see them super vividly. But we've been really lucky and blessed to see them here in North Georgia, especially once you get away from the light. You do need to get away from the light pollution, which unfortunately we do have a lot of here in Metro Atlanta. You need to kind of get away from the city to really see them shine. So let's talk about exactly what creates the Northern Lights, or the Aurora Borealis, whatever term you want to use for them. So the sun constantly has solar flares and solar wind kind of swirling around it. If you've ever seen like an animated image of the sun, you'll see things kind of spewing off of it. And so that is constantly happening, but occasionally they have those solar flares and that solar wind get so strong that it interacts with Earth's magnetic field. We do have a magnetic field that hangs out around us. Kind of keeps everything tucked in, right? And so when the solar wind interacts with Earth's magnetic field, essentially what happens is all of the charged particles in that solar wind, because as the sun kind of spews its molecules our way, everything that's wrapping around the sun all the time, those are highly charged particles. And what happens is they interact with our magnetic field and a lot of the particles in our atmosphere, like oxygen and nitrogen, to create this chemical reaction that results in these beautiful colors in the sky. So a lot of science goes behind it. It's kind of like if you took like a beaker when you were in chemistry class and you'd put different things in it and it would either bubble up or turn colors. It's kind of what happens in space, and then gives us a beautiful view of the color in the sky. So again, we have that solar wind that's constantly kind of moving around our sun, and sometimes those flares and that wind gets really strong enough that it interacts with Earth's magnetic field. And as soon as that happens, all the particles within that solar wind, they spread out, and our Earth, kind of as a protection mechanism, I guess you could say, deflects all of that towards the poles. So the poles are obviously, you have the North Pole and the South Pole. Our Earth tilts on an axis at the poles, just over 23 degrees, in case you were curious. But those charged particles within the solar wind interact with all the molecules in our atmosphere and in Earth's magnetic field, and they're channeled towards the poles. So that's why where you're going to see the Northern Lights most vividly and also more often, the reason it's in places like, Switzerland and Canada and Alaska, is because you're closer to the poles there. Now, also on the flip side, if you go to the South Pole, you'll be able to see them a little more commonly and frequently as well, and more vividly. But that's how that works. Essentially, when we have that interaction with Earth's magnetic field, everything gets deflected towards the poles. But sometimes if that is strong enough, everything can kind of start to spill south. So even though that energy is getting deflected towards the poles, sometimes it can kind of get trapped a little further south, which gives us that ability to view the Aurora Borealis, or the Northern Lights. So essentially, that is the process that happens, and it is not a dangerous process. It doesn't necessarily mess with anything. It can mess with, I guess, some signal when it comes to like cell phone towers and stuff like that, but it'd have to be really, really strong for that. So we're not worried about it. But regardless, that is the process in what we call geomagnetic storms. That's just a fancy word for Northern Lights and Aurora Borealis. So now tonight, we are predicting a G3 magnetic storm, so geomagnetic storm on the level 3. And that's considered strong. Last night's was a G4, which could again move into North Georgia, especially up in the mountains. Unfortunately, this level only will really bring the visibility of northern lights to maybe as far south as like Illinois. So maybe the mountains of Tennessee, of northern Tennessee, could also get in on this. But unfortunately, it doesn't look like it's going to grace our skies again tonight. So if you missed them last night, I'm sorry. But unfortunately, even though we do have another technically tonight, it's not going to be seen here in North Georgia. We're only going to, only our neighbors to the north will be able to really get a view on this. So that's what we're looking at in terms of the geomagnetic storm for tonight. Now, the different colors that you see in the sky, they are due to, and I didn't put this on a graphic because it would have just been way too wordy and way too just busy. So we'll just go back to my original graphic. But the different kind of molecules that are in our magnetic field, in our atmosphere, they interact with these solar winds and things like oxygen, which clearly we have plenty of here. Those create the colors that are more so like green that you see most often and most vividly. But then when you start to get into things like nitrogen and other molecules that are in the atmosphere, you get to see more of the purples and the reds and the really beautiful blues. So the most common color you'll see is green because that's when that solar wind interacts mostly with oxygen, which again, we clearly have plenty of here. But once you start to see the blues and the pinks, that starts to get a little more rare because it's just interacting with different molecules that aren't quite as plentiful. When it comes to our scales of geomagnetic storms, extreme, I'm not sure I've ever seen that happen. Here at least. Maybe I just haven't paid attention to it. But you could see the aurora as far south as Florida. So that's pretty rare. That doesn't happen very often. Of course, the G4 we have seen a couple of times already this year, one last night and one earlier in the year. And you could see it as far south as Alabama, Georgia, and the Carolinas. So I've seen just some really, really beautiful images out of the Carolinas from that. And we did have a picture from one of our coworkers here of the storm. So of the geomagnetic storm. Honestly, I think that's the best kind of storm, right? You can see all the beautiful colors in the sky. But again, for us here at home, not going to see any of the northern lights again tonight. But essentially how this all works is you have solar wind with charged particles, interacts with Earth's magnetic field, this chemical reaction goes off, and we see all these beautiful colors in the sky that look all wavy. And essentially, it's what you're watching is the process of all of these particles kind of going through their wavelength process. So when, if you think about the light spectrum that you learned about maybe when you were younger, and, the purples and reds are that higher frequency, shorter wavelength, and then you have the oranges and the greens and the blues, or the oranges and the reds that start to get on those longer wavelengths, lower frequency. So you're kind of seeing that process of those, frequency waves happening when you see all the curves in the sky. Anyway, that was my representation of Aurora Borealis, in case you were wondering. But that's how it works. And again, something that we've really been lucky to have quite frequently here and be able to see here in the United States. You don't have to travel super, super far to see them anymore, it seems like recently. That is not a bad thing. It's okay. But again, tonight we have a G3 storm forecast, which essentially means we're not going to be able to see it here in North Georgia. So if you missed it last night, we'll try again another time. And we'll let you know if we do have another chance at seeing any of the northern lights when we learn about that happening. But you'd have to go all the way up to about Illinois, up towards the Great Lakes, to see any of the northern lights tonight. So, all right, I hope you learned something new today and you enjoyed it. And if you do have any pictures from last night, if you were able to see the northern lights, be sure to send them our way. We would really love to see them. There were some beautiful ones. So enjoy the rest of your Friday. Enjoy the beautiful weather. Seeing lots of blue in the sky today because of all the beautiful sunshine. It's just been gorgeous. Thank you so much for joining us, whether where you are, and make it a wonderful day.